In October 2024, on the Klamath River at the Oregon-California border, the last concrete wall of Iron Gate Dam crumbled into the current, and a century of blockage ended in an afternoon. Within days, sonar registered 6,000 Chinook salmon pushing through where the dam had stood. Nobody had predicted that. For over 100 years, engineers built walls. The salmon waited. This is the story of what happened when the walls finally came down. The Klamath had been a severed river for over a century. 4 dams had turned its upper reaches into a series of warm, still reservoirs, dead water sitting behind concrete walls that most living Americans had never seen standing any other way. The fish had a name for what that water had become, written in their bodies. Chinook salmon navigate by chemistry. They read dissolved oxygen, temperature, and the mineral signature of the gravel where they were born. For more than 100 years, that signature ended at a wall. In October 2024, the last of the 4 dams came down. Iron Gate Dam, the lowest, the final barrier, went into the current, and for the first time in living memory, the Klamath ran unbroken from the Oregon highlands to the Pacific. The sediment was still moving. No revegetation plan was complete. The gravel beds were buried under decades of reservoir silt. Restoration ecologists had built careful models, recovery timelines stretching years into the future, cautious projections built on the best available science. Within days of the dam's removal, sonar equipment recorded more than 6,000 Chinook salmon passing through the site where Iron Gate had stood. Not in a season, not across a year, in days. Every hatchery program, every water quality intervention, every habitat study across the previous decades had failed to push wild Chinook back into the upper watershed in numbers anything like this. The fish did not wait for the restoration plan. They were already moving. The monitoring teams, the field biologists tracking passage counts at the former dam site, watched their projected timelines collapse in real time. A run this size, in the first autumn after removal, had not appeared in any of their models. The sonar kept counting. The program's biologists had modelled a cautious first-year return, a fraction of what arrived. The gap between prediction and reality was not a rounding error. It was a different order of magnitude entirely. What no recovery model had accounted for was this. Chinook salmon hold the memory of a river in their genetic inheritance across generations. A population blocked for over 100 years still carried the upstream coordinates inside them. And the moment the passage opened, that inheritance activated. Those 6,000 fish did not simply pass through a gap in the river. They pushed upstream into water that had not held a wild Chinook in most of their lifetimes. And they began to dig. Reds scraped into the gravel, eggs laid in a riverbed that had forgotten what they felt like. What the river did next, from the substrate up, is where this story really begins. The Klamath looked like a watershed. It moved, it bent around boulders, it caught afternoon light the way a healthy stream does. From the bank, you would never know you were looking at an ecological shell. Baseline surveys told a different story entirely. The substrate beneath that current had been smothered by reservoir sediment for decades, and the cold side tributaries that once fed temperature refuge into the main channel had been severed one by one from the system they supported. Iron Gate Dam alone had eliminated roughly 400 miles of historic Chinook spawning habitat, prime corridor, cold side runs, shaded reaches, all of it locked behind a concrete threshold for more than a human lifetime. 4 reservoirs pooled behind those structures, their standing surface absorbing summer heat until temperatures climbed high enough to kill juvenile Chinook outright. You do not need a predator to empty a nursery. You need the wrong temperature for long enough. In the Scott River tributary, Chinook counts had collapsed to a fraction of historic levels. The channel narrowed by decades of unchecked sediment load, the spawning substrate buried beneath it. Along the Shasta River reach, cold water refuges that once held spawning runs through August had contracted to isolated pools cut off from the main stem. At Iron Gate itself, the dam face was the biological ceiling of the entire system. Nothing upstream, nothing spawning across hundreds of miles of prime corridor. On the lower Klamath near the Oregon border, the Chinook and Yurok tribes had documented the near disappearance of a species that had sustained their communities for at least 6,000 years. That 6,000-year relationship between the Chinook and Yurok peoples and this run of Chinook had been reduced within a single century of dam operation to a word in a historical record. Copco Reservoir developed harmful algal blooms with enough regularity that communities along the lower reach issued public health advisories season after season. Livestock sickened. People who touched the surface were warned off. A reservoir that was sold as progress had become a seasonal public health event. The river looked intact. It was hollow. What no one in the restoration program had fully modelled was what happens when 400 miles of reconnected corridor meets a population that has carried the upstream address in its biology for generations, and the sediment pulse that preceded the Chinook into those reaches began doing something the engineers had not scheduled. The substrate was moving before the restoration teams could measure it, redistributing decades of impounded sediment across a corridor that had been starved of it. Whether that sediment pulse would smother the reds or rebuild them was a question the program's biologists could not yet answer. What comes next is the part of this story that rewrites what recovery is supposed to look like. The answer the agencies reached for first was not removal. It was replacement. Hatcheries went up along the lower Klamath. Concrete raceways filled with juvenile Chinook raised on commercial pellets, and the program called it mitigation. Those hatcheries produced fish by the millions. On paper, the numbers looked like progress. What the return data showed was a different story entirely. Hatchery Chinook came back at lower rates than wild fish, and the wild juveniles sharing the same water-loss ground every season. Pacificorp owned all 4 dams. At peak output, the combined system generated enough electricity to supply roughly 70,000 homes. The company held that figure like a shield against every removal proposal that reached the table. That figure deserves a second look. By the time the legal proceedings ended, the dams were generating a fraction of their designed capacity. The infrastructure had aged past its original operating licenses, and the electricity it still produced could have been replaced without a single ratepayer noticing the difference. The management strategy for more than 2 decades ran on 3 parallel tracks, none of which touched the dams themselves. Hatchery production scaled up. Flow schedules were written into federal agreements. Water releases were timed to seasonal calendars. The fish kept declining. Every dollar spent managing around the dams confirmed quietly that the dams could stay. And the salmon paid that bill in generations they were never allowed to produce. Entire year classes simply did not happen. Not because the fish were gone, but because the gravel they needed was locked away above 4 walls of concrete. What the programme's biologist eventually documented was this. An entire professional generation had studied Klamath Chinook without ever working a free-flowing reach above Iron Gate. They had no field baseline for what the upper system was supposed to look like when it was alive. More than 2 decades of legal proceedings, environmental review after environmental review, negotiated federal agreements stacked on top of each other. And when the final deal was signed, the dams had outlasted the licenses that originally justified building them. Nothing changed because the management strategy improved. The flow schedules did not save the run. The hatcheries did not close the gap. What finally moved the concrete was the slow, grinding recognition that there was only one tool that actually worked. And it had been sitting unused the whole time. When the last structure came down in October 2024, something happened that no flow schedule had ever produced, and no hatchery had ever replicated. Within days, sonar was counting fish at the breach, not hundreds, not a trickle testing the new opening. The number that came through was 6,000. What those fish did next is what nobody had the data to predict. The current was already rewriting the riverbed before those fish reached the first bend. Water freed from a reservoir does not meander politely. It accelerates, finds its old gradient, and begins stripping a century of accumulated silt from the stone beneath. Sediment moved in pulses. The first flush temporarily buried stretches of lower river habitat under a layer of fine material. Then, as that load dispersed and settled, something older appeared underneath. Cobble and gravel, the coarse substrate that had been locked under still water for generations. That gravel matters in a way that is almost mechanical. A Chinook female excavates a shallow depression in the stream bed, and buries her eggs in the stone. Current flowing upward through the cobble carries oxygen directly to the clutch. Without that flow, the eggs suffocate. It is that simple. Those 6,000 Chinook recorded at the breach were not scouts. Their bodies were already in spawning condition. The hormonal shift had happened weeks earlier, timed to a migration that the river had finally allowed to complete. They moved upstream into reaches that had not held a single red in over 100 years. Then the carcasses began to accumulate. Each adult that spawns and dies carries something invisible but measurable. Nitrogen and phosphorus pulled from the open ocean and deposited into a watershed that had been running nutrient poor for a century. The river was being fertilized from the inside. The biological sequence that followed needed no direction. Insects colonized carcasses within hours of deposition. Stonefly and mayfly populations responded to the nutrient pulse within days. Riparian vegetation along newly wetted banks began recruiting new growth within the first season. Stoneflies and mayflies are not incidental. They are the first food a juvenile Chinook encounters after absorbing its yolk sac. A reach without invertebrates is a reach that raises no young. The nutrient pulse from 6,000 spawning adults was seeding the very food web those adults' offspring would need the following spring. The chain had 4 interlocking layers, and none of them required intervention. The gravel held the eggs. The current oxygenated the clutch. The carcasses fed the invertebrates. The invertebrates fed the juveniles. Each layer had been absent, not destroyed, absent, waiting for water to move at the right velocity again. The programme's field biologists noted something in their first season surveys that sat outside any projected recovery model. Red counts in reaches above the former Iron Gate site were appearing at densities that the pre-removal assessments had not assigned to year 1. Densities the models placed somewhere in year 3 or year 4 of a gradual recolonization. 2 years of juveniles will need to survive the full ocean cycle before that number has any meaning. What those returning adults carry back, in their bodies, in the nutrients, in the next generation buried in new gravel, will tell a story the sonar cannot yet read. The river is already writing it. The projections were careful. Biologists had built their models on a century of caution, on the assumption that a watershed locked for 4 generations would need years to remember what it once was. The fish did not wait for the surveys. That same autumn, Chinook were documented in tributaries upstream of the former DAMS sites, reaches the monitoring crews had not yet formally assessed for suitability. The biology moved faster than the paperwork. Biologists had assigned meaningful upper watershed use to year 3 or year 4 of recovery. Documented spawning arrived in year 1. That gap is not a rounding error. It is the distance between a model and a living system. Sediment flushing, modelled as a gradual multi-season redistribution, moved faster than the engineers had forecast. In some reaches, substrate was exposed ahead of schedule. In others, heavier deposits than anticipated briefly pressed down on habitat that had held the lower fishery intact through the entire dam era. That lower river stress was real, and it mattered. The communities downstream had watched those reaches sustain fish through a century of compromise. Seeing that habitat temporarily pressed by the liberation they had fought for, that was not nothing. Farmers and irrigators had drawn on reservoir storage for dry season supply across decades. With the managed pools gone, and the flow regime unregulated, that supply became uncertain in ways that no stakeholder agreement had fully resolved. A living system restored is not a problem solved. It is a different set of problems begun. And here, roughly 2 seasons into the free-running Klamath, the sediment load moving through the middle reaches was carrying more than silt. It was carrying the first measurable pulse of marine-derived phosphorus, delivered by returning adults, into substrate that had run nutrient-poor for 4 human generations. The mechanism was working, but 3 downstream irrigation districts were still negotiating water share agreements that the dam era had made unnecessary to ask. None of this was clean. The Klamath did not recover on a schedule. It recovered on biology's schedule, which moves faster in some directions and far messier in others than any plan written by people who had never seen it run free. The field teams will spend the next 3 to 5 seasons mapping exactly which tributary reaches held and which were overwhelmed by the sediment pulse. Those results will determine whether the upper watershed use recorded in year 1 was an anomaly or the leading edge of a wholesale redistribution of where this run lives. What the communities along this corridor are negotiating now, land, water, growing seasons measured against salmon runs, will shape whether the biology has room to finish what it started. The fish moved faster than the models. The harder question is whether the institutions can. The land along the Klamath does not know the dams are gone. It just knows the water is moving again, cold, carrying gravel, cutting new channels into banks that spent a century holding still. That is the thing nobody in the planning rooms could quite write into a document. Remove the obstruction, and the river does not wait for a recovery framework. It simply resumes. The Klamath did not come back because of optimism. It came back because physics does not negotiate. 4 dams blocked this river for over a century. In the same autumn they came down, the run appeared, not in a season, not in a decade, the same year. Every barrier humans built to manage that river was a door they could have opened at any point. The only thing being spent while they debated was generations of Chinook that never found their way home. Now we follow the grey wolf back into the Colorado Rockies. A population reintroduced in late 2023 has already pushed beyond every predicted territory boundary. Those wolves are restructuring elk behaviour across thousands of acres of riparian corridor that have been overgrazed for 40 years. When elk stop lingering at a riverbank because something is watching from the tree line, the willows come back. Colorado parks and wildlife faced legal challenges in 2024 from ranching interests arguing the reintroduction violated state land use agreements. The wolves, indifferent to that argument, had already crossed the state line. What happens to a river valley when the animal that used to terrify everything drinking from it comes back? And whether that fear is exactly what the system was missing all along, that is what the next valley is about to answer. Tell me where you live, and tell me one creature, a fish, a bird, anything that was common along your stretch of river or coast when you were young and is simply gone now. Drop it in the comments. The place, the animal, the decade it disappeared, and yes or no in the comments. Have you ever seen something come back that you were certain was gone for good? Because if the answer is yes, I want to hear that story. Share this with someone who still believes the damage is permanent because the evidence says otherwise.